Hello friends, let's see today redox chemistry, reduction, oxidation chemistry. In our day-to-day life, we see lots of redox reactions like digestion of our food inside stomach, rusting of iron, in metallurgical process means for extraction of particular metal ion from the ore. These are the few examples of redox chemistry. Then what is it? Let's see. First we will see reduction. What is reduction? It is nothing but the gain of the electrons. For example, chlorine atom, since it has 2,8 chlorine atomic number 17287, it requires one electron, and that's why this chlorine is going to accept one electron and becomes minus. This process is reduction, that is gain of electron. At the same time, if you see sodium atomic number 281, and it will lose this one electron so that it gets Na plus electron to attain the electronic configuration of nearest inner gas element, that is neon, and that's why it loses one electron to get stabilized, and hence loss of electron has been occurred. This is called as oxidation process. And if you combine these both processes, oxidation, reduction, means at the same time loss of electron will occur, and simultaneously some atom will gain that electron, that is the reduction will also occur. And after combining these two processes, that is transfer of the electrons from one system to another system, from one species to another species, is the redox reaction, redox process. Right. Let's take another example. In case of Al2O3, aluminium, we know aluminium is in +3 state. These 3 electrons will get transferred to oxygen, O2 minus. And here also there is oxidation reduction process. If we come back to again above process, see, sodium is losing one electron, chlorine is gaining this one electron, and hence Na plus Cl minus, it becomes NaCl. This is the redox process. Now we will see next is how to find out oxidation number of the species. Now let's see what is oxidation number. Oxidation number is the measure of extent of oxidation of an element in its compound. Oxidation state means any atom will have a charge. After removing all the attached atoms from it is the oxidation number of that element, of that atom. Since there are few sets of rules which we have to follow to find out oxidation number of particular atom, particular element in the given species. And what are those sets of rules? Let's see one by one. Number 1. If atom is present in any allotropic form, then its oxidation number will be 0. For example, diamond is made up of carbon. We have to give oxidation number for that carbon as a 0. Second, charge of any monoatomic ion will be charge equal to present on that ion. For example, sodium. Sodium generally we write Na plus, then the oxidation number will be plus 1 or 1. And if you consider chlorine, Cl minus, we give Cl minus as a charge, then its oxidation number will be minus 1 or 1. Third, if we consider any molecule, then its total oxidation number for that molecule will be 0. For example, ammonia or water, since they are neutral molecules, their charge, the sum of their atomic charge will be 0, and hence oxidation number for a particular molecule, neutral molecule, will be 0. But if it is any ion, if we consider it as an ion, for example NO2 minus, then charge of nitrogen plus charge of 2 times oxygen will be equal to minus 1. Fourth, we know fluorine F minus, fluorine has the highest electronegativity, and hence its charge, its oxidation number will be minus 1 always. F fluorine we have to give minus 1 as oxidation state always. But now if we consider oxygen, oxygen has some exceptional cases. Which are those? In water, we write it oxidation number of oxygen as a minus 2 because O2 minus. But if we consider hydrogen peroxide H2O2, here oxidation state will be how much? 2 hydrogens are giving their electrons to 2 different oxygen, will be minus 1. But if we consider OF2, since the fluorine is FO2 or OF2, then fluorine is having the highest electronegativity, its charge is minus 1, then oxygen will have plus 2 as its oxidation state. Means see, oxygen is having some exceptional cases. If we consider hydrogen, we know H always in H plus proton form, that is its oxidation number will be plus 1. But sometimes it is also present in a hydride form, H minus, and in that case it will be minus 1. If we consider any covalent molecule, means 2 atoms which are attached and they have nearly same electronegativity, then for example H2O2 N2 or P4 S8, right? Since phosphorus is attached to the same atom, phosphorus, it is having covalent bond, and in that case total oxidation number will be, we have to consider 0. And at last we will see how to calculate its oxidation number in a particular species. For example, again if we take a nitrate, then we have to add the oxidation number of nitrogen plus oxidation number of 3 oxygen, and their addition will be equal to the total charge over the species, that is minus 1. And in this way we are going to calculate the oxidation number in particular species. In summary, now we will see for the oxidation number. For the allotropic form, oxidation number will be 0. For a monoatomic cation Na+, it is having plus 1 charge. if we consider negative spaces, Cl minus, it is having -1 charge. For neutral molecules NH3H2O, oxidation number will be 0. Fourth case, fluorine is having the highest electronegativity. It will always have -1 oxidation state. And in the fifth case, oxygen is having some exceptional cases. For example, water H2O, oxygen is having -2 charge in O2 minus oxide form, whereas if you consider peroxide H2O2, it is having -1 charge. If we consider F2O, oxygen is having +2 charge, and sometimes even KO2, since K is plus charge, oxygen is having here -half charge, that is +1 charge will be distributed by 2 oxygen, and in that case each oxygen will carry -half charge. Sixth point, hydrogen. Hydrogen, we always know it is in proton form, it is H plus. It will have +1 oxidation state, but some hydride compounds are also we know, and for that it will be the -1 charge. For certain covalent molecules like H2, O2, N2, P4, S8, here the total oxidation number will be 0. And how to calculate the oxidation number for particular spaces, now we will going to see. Let's find out oxidation number of particular atom in a particular spaces. First example is H2SO3. Let's find out oxidation number for sulfur. Let it be X. Then how we will find it? Let's see. We know hydrogen is having always +1 oxidation state, and since there are 2 hydrogen atoms, it will be multiplied by +1. Now we have to go for next atom, and we will give positive sign plus. Sulfur, there is only 1 sulfur, and hence 1 into X, since we have assumed as a X. Again we are changing the atom, we are going towards oxygen, plus, since there are 3 oxygen, 3 into, we know common oxidation state for oxygen is -2. We will multiply it by -2. And H2SO3, since there is no overcharge and it is a neutral molecule, therefore total oxidation number of the species is 0 as it is neutral. And on solving this, 2 plus X minus 6 equals to 0, therefore X equals to +4. Next example we will see phosphatide, PO4 3 minus. Let me find out oxidation state for phosphorus, and let it be X. Then there is only 1 phosphorus, 1 into X. We are changing the atom, positive sign. There are 4 oxygen, 4 into, we know oxidation state of oxygen is -2, and equals to, see the overall charge is -3, and therefore X, 4 2s are 8, -8 equals to -3, therefore X equals to 8 minus 3, and oxidation state is +5. Another example, third example, let's take it. For potassium dichromate, Kr2O7, you can write it as, okay, let's find out oxidation state for chromium. Let it be X. 2 times plus 1, since we write it as a K plus 2 into plus 1, plus there are 2 chromium, 2 into X, plus there are 7 oxygen, 7 into minus 2. Since the oxidation state of oxygen is minus 2 into 7, and overall charge it will be 0, since the above charge is not there and it is a neutral molecule, we will give it as a 0. 2 plus 2x minus 7 is 14 equals to 0, and therefore 2x equals to 12, and x will be plus 6, and therefore chromium will have plus 6 as its oxidation state.